So welcome to Electronics XLA, and we are in digital electronics lecture series, and today the topic of discussion is the binary arithmetic. Okay, so in this lecture we will see uh, what is sign and unsigned numbers. Okay, and how the binary numbers are means added, subtracted, and multiplied and divided. Okay, so basically the binary digits in the binary arithmetic will deal with only two digits, that is 0 and 1. Okay, so how it can be means added, subtracted, multiplied, and divided, that we will see in this lecture. Okay, so let us start our discussion. So binary arithmetic. So this binary arithmetic is an important uh, operation in the digital computers or many digital systems. Okay. So a binary number, as I have told you, uses only two digits, that is 0 and 1. Okay. So that is why the base of the binary number is 2. So it uses only two digits or any two symbol, that is 0 and 1. Okay. So the arithmetic operation, as I have told you, will study addition, subtraction, multiplication, and division. Okay. So the this arithmetic distinguishes the signed and unsigned binary numbers. Okay. So it is signed binary numbers. Actually, signed binary number means there is a sign bit. In this type of number, there is a sign bit. Okay. That sign bit actually placed in as the most significant bit. Okay, or it is written as MSB. Okay, that's the most significant bit. So and remaining bits are the magnitude bit. So it is the number that is consist of sign bit plus magnitude bit. Okay, so sign bit is a single bit which is in the MSB bit. So in the sign binary we have means uh, we will discuss in the separate lecture, okay, of sign binary numbers. But in this case, actually the sign numbers having two parts. One is a sign part, another one is a magnitude part. The sign part actually reserved for the MSB bit. Okay, suppose we are dealing with the means is 8-bit sign binary number. Okay, so in this case, the first bit it is reserved for the MSB bit, which is reserved for the sign of that number. So this is the sign bit. The remaining bits you can see, the remaining bits are the called the magnitude bits. So this is the sign bit. This single bit. Okay. So this is the sign bit. This is the magnitude bit. Okay. So this is the signed binary number. Okay. And what is the unsigned binary number then? The unsigned binary numbers are the numbers which has only means sign bit is not specified. Okay. So sign bit is not specified. All the bits are considered as the magnitude bits. Okay. In the unsigned number, binary number, all the bits are magnitude bits. It is not don't have any means sign bits. Okay. So key idea: the binary arithmetic is a fundamental to any digital systems. Okay. So binary addition. Then we'll see what is the binary addition, how the binary addition can be done for the sign means from the binary numbers, not sign, only binary numbers. Okay. So this sum, if we have sum, this result of the addition operations, the sum is the result of the addition operations. Okay. So there is a carry also that we have the carry value. Okay. So these two numbers which are added are known as augment and added. Okay. So these are the 2-bit operation. So these are the 2 bits operation, and this is a 3-bit operation. So 0 plus 0, the sum is 0 and carry is 0. This is where I am talking about the binary addition. Okay. So 0 plus 1, the sum is 1 and the carry is 0. Similarly 1 plus 0, the sum is 1 and carry is 0. Okay. The 1 plus 1, what is 1 plus 1? The 1 plus 1 is a sum is 0 and carry is 1. Okay. So 1 plus 1 is just sum 0 and carry 1. So we have a carry bit over here. So then 1 plus 1 plus 1, sum is 1 and carry is 1. Okay. So this is how the binary addition means done. These are the 2 bits, 2 and this is a 3 bit. Okay. So this is our operation. That is the binary addition. Okay. So this is the important is that the 1 plus 1 is a 1 0. You can write 1 0. Is this 0 is a sum and 1 is a carry. Similarly 1 plus 1 plus 1. This is the 1 and 1. So 1 is a sum, another one is a carry. Okay. So there is a carry generated. Okay. If we have needs as in second binary digits. Okay. Next one is a binary addition. Some examples you can see this one is a means 0, 1, 1. It will be added with 1, 1, 1. So 1 plus 1. 1 plus 1 is 1. What is 1 plus 1? 1 plus 1 is 1, 0. Yes, sum is 1, then carry is 1. 1. Okay. So this is 0, then the carry is 1. Okay. So that 1 plus 1 plus 1. What is 1 plus 1 plus 1? That we have to studied 1, 1. Okay. So 1 plus 1 plus this is 1 is sum. There is a carry over here. Okay. And 1 plus 1 that will be 1. Okay. So this is our result of that additions. Okay. Similarly, for example, this example you can see 0 plus 0 that is 0. Then 0 plus 1 that will be 1. Then 1 that will be 1. Okay. So this is our example C, that is the 1 plus 1. So 1 plus 1 is a 0. Okay. Similarly, means there is a carry over here. So 1 plus 1 plus 1, it will be 1. Okay. Then there will be carry. So 1 plus 1, that will be 1. So you can check over here also that once again. So 1 plus 1, it is 0 sum, the carry is 1. Then similarly, 1 plus 1 plus 1, that is 1, 1. So this is 1 and this is a carry is 1. So 1 plus 1, that will be 1, 0. Okay. This is the last example. So 0 plus 0, that is 0. 1 plus 0, that will be 1. Then 1 plus 1, that will be 1, 0. Okay. So these are the some work example of binary additions. Okay. So add from right to left and propagate each carry to the next positions. This is the rules of addition. Okay. Similarly, binary subtraction. So difference. So result of the subtraction is a difference. Then we have a borrow also. Okay. The digit got back from MSB position to the subtrahend digit is larger than the minute. If the subtracted digit is larger than the minute, then we have a borrow. Okay. So what is the, it means what is minute and subtrahend? You can see if we are differentiating a B from A, so A is the minute and B is the subtrahend. Okay. So if B is greater than A, then we have a borrow. Okay. So the addition escape the on-side match. These are the on-side binary subtractions. Okay. So rule you can see 0 minus 0, that will be 1. So 1 minus 0, that will be 1. Then 1 minus 1, the result is 0. Now this 0, this is the, in this case you can see that is actually 0 minus 1. So 0 minus 1. Okay. So what will be the 0 minus 1? So we now you have to borrow 1 because 0 is less than 1. Okay. So you have to borrow 1, that is why there is a 1, 0. So 1, 0 minus 1, that will be 1. Okay. So 0 cannot be subtracted from means 1. Okay. So you have to take some borrow. So 1, 0, we have a borrow 1. So the result is your 1. So 1 is the difference and borrow is your 1. Okay. So this is the actually if you have 0 minus 1, then the difference is 1. Okay. The difference is 1 and borrow is also 1. Okay. So this is our difference or subtraction operations. Okay. Next reason, a borrow is needed when the minority digit is smaller than the subtrahend digits. Okay. So this is a work example. You can see 0 minus 1. So 0 cannot be subtracted from 1. Okay. Or 1 cannot be subtracted from 0 actually. 1 cannot be subtracted from 0. That is why you need to borrow 1 from this digit. So it will be 1, 0 minus 1, it will be 1. It will be 0. Okay. We have this is the we have taken borrow from this bit. Okay. So that will be 0. Okay. So 0 minus 0 it will be 0. Similarly 1 minus 0 it will be 0. 1 minus 0 it will be 1. That is 1 minus 1, that will be 0. Okay. So this is how the subtraction are done. Okay. So this is a second example also you can see. Okay. So this is the bit that we need to take borrow from this bit. Okay. So that will be 1, 0 minus 1, that will be 1. Okay. So that will be 1, 1, 0, 0. Okay. So now you can subtract from right to left, use a borrow when required. Okay. So rules, binary multiplication. Then we have the binary multiplication. This is the same way we are doing in the digital decimal multiplication. Okay. Process is same. Okay. From the partial product, then shift each partial product to the left, then add the partial products. This is the rule for multiplication. So we know that 0, if it is multiplied with 0, the result is 0. Okay. Only 1 multiplied to 1, the result is 1. Okay. So partial product actually the multiplier bit of 1 is produces a multiplicand in the partial product. A bit of 0 produces 0. Successive rows are shifted towards the left. Okay. So let us see some examples. So key idea is that you have to shift the left plus add partial. So it is the same way that of the normal multiplications. Okay. For some examples you can see that is the 1 multiplied with 1 1. So 1 into 1 that will be 1. Then 1 into 1 that will be 1. Then 1 into 1 shifted 1 position to the left. So 1 into 1 that will be 1. So 1 is this one. So 1 plus 1 is 1 0, that is 0. Then 1 plus 1 it will be 1 0. Okay. So 1 0 0 1. Okay. So let us take it. So 1 1 in multiply with 1 1. So 1 into 1 1. Then 1 into 1 that will be 1. Then 1 into 1 that will be 1. Then 1 into 1 that will be 1. Okay. So 1 that is the 1. The 1 plus 1 is your 1 0. So 0. Then that 1 plus 1 equal to 1. Okay. So this is how the multiplication is done. Okay. Similarly, you can verify this. Okay. So that will be all are ones are there. So that will be 1 0 1 1 0 and 1 1 0 1. Just add. Okay. So we will get this answer. Okay. So that is the thing. So this is the summary. So this is the result of this multiplication. Okay. As last thing is the binary division. Okay. So binary division follow the same procedure again as the decimal division. The divisor must not be 0. Okay. The operation provides 4 basic division cases. So you can see 0 divided by 1. So it will be 0. So 1 by 1 it will be 1. 0 by 0 it is not allowed. Okay. So it is indefinite. Then 1 by 0 that will be infinity. So it is also not allowed. Okay. So only we are allowing that 0 divided by 1 and 1 divided by 1. Okay. So division by 0 is not allowed. You can see division by 0 is not allowed. So 1 divided by 0 that cannot be allowed. So division must not be 0 in the binary division. Okay. For any division, the division must not be 0. Okay. So next was the example you can see. So 1 1 1. So 1 1 1 1 1 0. Sorry. So it will be divided with 1 1. So normal division. So 1 1 that will be 1. So 1 1 that will be 0. So 1 1 0 0. Okay. So this is how the binary division is done. Okay. So again this is 1 1 0. You can divide. You will get this 1 1. Okay. So this is the binary division. Okay. So binary long division. So compare the partial dividend with the divisor. Determine the quotient bit, subtract when appropriate, and bring down to the next bit. So binary arithmetic, let us sum it up. Okay. So operation addition, what we are doing, adding from right to left, and we have sum and carry. Similarly, where for subtraction we are subtracting right from to the left. Then we have the difference and borrow. Then multiplication, we got the partial product. Then shift left. Then add. Division we normally by using the binary long division, but the division must not be 0. Okay. So addition carry may be generated, subtraction means borrow is there, multiplication you have to shift and add, then division the divisor must not be 0. So division by 0 is not allowed. Okay. So these are the examples we have solved in this class. Okay. So please take it out for addition, subtraction, multiplication and division. Okay. So you can see, so you can track your carry and borrow carefully. For multiplication, shift the partial products. For division, never divided by 0. Okay. So you can practice at your home. These are the assignment for you. Okay. So that's all. So we have seen which operation generates a carry. Sum operation. So when is borrow is required, when my node is less than the subtrahend. So 0 and 0 by 0 is not allowed because 0 by 0 is not a valid quantity, and 1 by 0 also not allowed. Okay. So means because 1 by 0 anything divided by 0 it will be infinite. Okay. So that's all. Okay. So we have what we have learned in this lecture. The signed binary numbers uses 1 bit, usually MSB for the sign bit, and the remaining bits are the magnitude. Unsigned binary numbers treats all the bits as the magnitude bits. So signed binary number we have a one bit, that is the MSB bit, is reserved for the means sign bit, and on signed binary numbers treat all the bits at the magnitude bits. Okay. So binary addition uses sum and the carry. Binary subtraction we have difference and borrow. Multiplication we have the partial product, then we have to shift left, then add. Okay. Then binary division, general way of doing the decimal division. Okay. So division by 0 is not allowed. Okay. Next one is a quick revision. So these are the addition operations. So you can add. So 1 plus 1, there is a means carry is there. Sum is 0 and carry is 1. Okay. So if we subtract, you can see 0 minus 1 is actually you have to borrow 1. Okay. So that is 1 0 minus 1, that will be 1. So in this case the difference is 1 and the borrow is 1. Okay. Multiply only any quantity that is multiplied 0, the result will be 0. So 1 multiplied with 1, that will be 1. Okay. And division, so division that same way that done in the non-decimal division, only you can see that 0 divided by 0 and 1 divided by 0 is not allowed in the division process. Okay. So that's all. So you can practice the binary operation at your home. So next class we will see the signed binary numbers. Okay. So thank you all.